Hey, hi everyone. Welcome to the another day in our Python series. So far we have discussed about multiple things in our videos. So if you have seen, we have discussed about star ARGS, star KWARGS. Then we discussed about keyword and positional argument. Then we discussed about default parameters. So then we discussed about return statement. We discussed about parameters and arguments, what are the differences between them, how should you call them. Okay, so I have discussed about everything, and then I have discussed the defining and calling functions. So far we have discussed about this many stuff. So today what we do, today we will continue from that part. So this was the part 1 which we discussed so far, and today what we do, today we will continue with the further discussion of our analysis. Okay, so the last part was star ARGS and star KWARGS. Okay, and now in today's session we will understand regarding local and global, local and global, sorry, local and global concept inside function. Okay, we will understand about local and global concept in functions. We will work on that today. Okay. So what is local and global function thing that we wanted to know? So first what I do is simply create some examples to explain it to you. Okay. So let me just create the first example. Okay. Local versus global. Okay. This is the first example that I'm creating right now. So let us say I'm writing one thing called message. Message equal to I am global. Okay, this is the simple message that I am typing right now. I am global. Okay, and I am choosing this as my global variable. So I'll tell you what is global variable here, but for now you just assume that this is a message which is a variable, and the message variable name is I am global. This is the global variable so far. Okay, then I'm defining one function, def show scope. This is one function that I'm creating here. Okay, what this function will do, so inside this function I will type another thing called message equal to I am local. I'm typing this message inside this function. Okay, so this message is different than this message. Okay, this is outside the Python function, this is inside the Python functions. Okay, great. And I just simply comment it like local variable. Okay, local variable. Are they good? Okay, local variables. Okay, so what I simply do, I simply print a string inside function, then message. Okay, and then what I do, my function is done. Then what I do, I simply show the scope. So scope, I simply show the scope. I mean, I'm just calling the function so scope, and then I'm printing outside function. And then what I do is simply copy paste this message here. So now before executing the code, you just think. Okay, so I have written message equal to I am global. Then I have defined one function called show scope, and after that I have defined another message inside that function, that is I am global, and this is a local variable. Okay, then I'm printing inside function message. So when I'm calling the show scope, what will happen? So when I call this show scope, it will execute this function, and whatever lines are mentioned inside this function, it will be executing that. That's the main idea. So as per this function, this message variable exists in this function, message equals to I am local. So then it will print simply inside function I am local. But when outside the function I am simply printing outside function then message, then this message will print this I am global. If I execute the code, you will see it. See, this one printed I am local, but this one printed I am global. Why? Because for this function show scope, for this function, this message is a local variable. Okay, but this message is a global variable. Let me explain with some real world examples. Let us say that let's say you have some children live near your home, right? And tomorrow yesterday you got to know that they were lost. Okay, so how do you start searching about them? First you will check with your neighbors only. Are they there? Are they inside any one of your neighbor's house? Once you are not able to find them in your neighbor places, then you will go beyond neighbor places. Maybe you try to go outside your hometown, right? You will look around there, correct? Then if you are not able to find there, what you do, you will go more beyond. You may leave your hometown, if you leave your home city, and then you may find them somewhere else outside of your city itself, right? This is how police does their own entire analysis, right? So same thing is happening here. So whenever I call no scope, and this is something message I have defined inside my function, then when I'm printing inside function message, what it does, so this Python function, I mean entirely Python, what it is doing, it is trying to find, do I have any message variable available inside my function? This is the first step it will do I have any message variable available inside my function? In our case, yes, it is. Okay, but what if I just comment this section, and if I execute, now see, now this is printing I am global. Why? Because this message I have defined already outside. So what is the flow here? First, this message is checking, do I have any message variable inside my function? So previously we had, but right now we don't have, because I have commented this section. So it is not able to find it locally, right? Now what it will do, it will go to global. It will check, do I have anything available outside the function? Do I have anything, any variable message available outside the function? Yes, we have a message available outside the function, and that is the I am global function that is available here, right? So because of that, when I'm calling show scope, it is first checking, do I have message variable inside my function? If yes, print it. In our case, currently we do not have, as I have commented this section. It will check, do I have message variable globally available, that is outside the function, and it is available right now, and that's why it has printed I am global. Okay, and now if I uncomment this section and if I execute the code again, you will easily see that it is printing I am local. Okay, so I hope this example is also clear. Okay, great. Now we'll discuss about something more. Okay, now we discuss about something more, that is some other examples. Example 2 to explain these things to you far better. The global keyword, I'll explain you this one, the global keyword. Okay, the global keyword, I'll explain the global keyword also. Let us say I'm writing one variable called counter equals to 0. Okay, counter equals to 0. Then what I'm doing define increment. Function name is increment. I'm doing global. See, global color got blue. That means it is Python's inbuilt. Python has global variable. Okay, it's Python's inbuilt thing. Okay, so I'm writing global, then counter, global counter. So what I'm doing, this was a simple variable, right? It was a simple variable, counter equal to 0. What I'm doing, I'm telling you have to be global variable. I'm forcefully telling it you are a global variable now. Okay, then I'm simply doing counter plus equal to 1. Okay, now let us say I am calling increment. One time I called increment, 2 times I called increment, 3 times I called increment. Okay, so what it will do, 0 was the initial value. If I called increment 3 times, it will keep on at 1 3 times. So the counter value should be, if I print the counter, it should be 3, correct? Because I called this increment 3 times and I'm adding plus 1 for each of the execution. So that counter value should be 3 if I execute the code, and if I print the counter, see, it is 3 now, right? So this is the use of global variable. But now you will ask me, why did you use global variable here? I'll show you. Let me do this. Now what I am doing, I just replace this line itself. I will not write any line. I'm just saying counter equal to 0. Then I'm again same function increment, counter plus equal to 1. You will see what will happen. See, I got an error. What is the error? Unbound local error. So cannot access local variable counter where it is not associated with a value. So when I have tried when I tried to call this function define increment, and when it is trying to do counter equal to this line means simple, this one only, counter plus 1, but I do not have any variable available counter inside it. I do not have any variable available counter inside the function. It is not able to find counter. So how does it update then? It is not able to find a variable called counter inside the function. So that is it cannot update it also. But when I told global counter here, so now this variable became global, available globally. I mean available for the entire Python stack in Google Colab. Okay, or when you do in your laptop, it will be for your laptop stack. So that is why when I said global counter, now when it is doing counter plus equal to 1, it is able to find out this counter, and it is updating actually this counter value. And that is why when I executed this code 3 times, I got the value as 3 as an example. Okay, great. Let me just show you a few more examples here. Okay, so that we can better understand. That is example 3, LEGB rule. I'll explain LEGB rule, local, then enclosing, then global, then built-in. This is the LEGB rule that we need to understand. Okay, so what happens in LEGB rule? Let me just show you. Let's say I am defining something called x equal to global. X equal to global. Then I am defining one function. Define outer. So outer is the function. Then I am saying x equal to enclosing. So again I have defined x here outside. Then I am defining another x inside outer function. Okay, please check the hierarchy. Okay, then I am defining another function inside another function. So inside the outer function, I can define another function also. So I am defining the function called inner. Then I am doing x equal to local. Okay. Then I am printing, simply I am doing a string print inner sees x. Okay. Then I called inner inside the outer function, and then I have printed outer sees x. Okay, and then I'm just calling the outer function. Then I'm printing simply global sees x. Okay, this is the thing. Great. So now what is the eligibility is talking about? I'll explain. Just understand the hierarchy. I have defined one thing called x equal to global, then define outer, x enclosing, then inside outer function I have defined another function inner where x equal to local and print inner sees x. Then I called inner function, then I called outer function. I just execute the code. See what is happening. First, when I executed the outer function has executed this function first, inner, right? And inner is this function. Okay, correct. For the inner function, x equal to local. So that means this x variable which is printing right now, for the x variable, this is the local one, because this is the inner function and I am trying to find x. So where I will first search, I will first search in my local step, right? And that is why it has printed inner sees local. That means it has tried to find out that do I have any variable x available in my function? Yes, inner has x inside it. Then when this line was called, then it has executed this line, print outer sees x. Now when you see inside outer functions range, I have x equal to enclosing. Now what is happening? This x is trying to find in its local section. It will not try to find inside the inner section. No, it will not. It will always try to find where this function is enclosing. Inside this range only. It will not look inside this inner function. Okay, it will not look inside the inner function. Okay, it will look in its local section first. So it is saying that okay, my X is available in my local setup. That is why it is printed enclosing. And later when I printed global is X, then this X became global variable here. So we got global. And now let us say if I just simply comment out this section. So inside inner function, I am just commenting out the X. So now what will happen? Let us see. See, same hierarchy. See, first when I called outer again, this inner was called, inner was this function, and when it is tried to print X, it could not find X because X is commented. What it did, it went one hierarchy up. Then it checked, do I have any X available inside outer function? And I had X equal to enclosing. That is why it is printed inner is enclosing now. And same for outer now. And same for global now. Now if I just comment this X also, then what will happen? See, now everything will come as global. Why? Because first this inner X could not find X in it, inside it. It tried to find inside outer. It could not find inside outer also. What it did, it again went back to outside and it is trying to find globally. Do I have any X variable available here or not? This is the hierarchy that it always follows. And this is called as LEGB rule. Local, enclosing, global and built-in. If I explain first of all the local thing. So when I just called X here inside inner function, it is trying to find out, do I have X available in my local? This is the first step that it will do. Now then when it was not able to find X inside the inner function, it tried to find the enclosing section because this inner function is enclosed by the outer function, correct? That is why when it was not able to find out X inside its local setup, it went to the enclosing hierarchy. So it was enclosed with the outer function. It was trying to find, do I have any X variable available inside the enclosed function or enclosed space? It could not find out. Then it went global, like the globally I have defined it here. Then it was able to find out. But let us say I do not have global variable also. Then this code will throw an error, by the way. I mean, this will not throw an error because this code, this X is already stored inside our logic, okay? I mean, inside our memory. That is why even if I comment it, this is working. But if I just restart the kernel, right? If I simply restart the session, if you see, and let it restart. So if you see when I'm restarting this and executing the code, you shall get an error called X is not defined. Okay, but when it will not be able to find out a global variable, I mean globally when it will not be able to find out, it will try to search in the built-in. Built-in means something Python has written for themselves behind the scene, like global, right? This global thing that I called, this was Python's written inbuilt or built-in thing, correct? So that is why once it will not be able to find out into the global space, it will check, do I have anything available into the built-in stage or not? And since this X it could not find into built-in stage also, that is why it threw an error that name X is not defined. Hope I was able to explain the LEGB rule to you. Okay, great. So now what I do, I will simply now discuss about a nested functions, which is a very important topic, that is called nested function. Nested function. Okay, so what does it mean a nested function? So functions defined inside other functions. So I have already showed you one example already, right? But still I am just separately explaining this to you. So nested function is nothing but functions defined inside function. Again, example 1 I will show you. Example 1. Okay, so helper function, we will build one helper function inside a main function. Okay, we will do that. I will just show you. Okay, so first I am defining one function called process grades. Okay, this is a function which will process grade, and since this function will process grades, it will take grades as an input. So help us grades here, grade. Now I am inside my function. Now what I do, I will write a helper function which will help me to do something. What it will help me? Since this will be a grades, right? List of grades. So now each grades will contain a list of numbers, right? So what I do is simply create a function as a helper function, get letter. So it will take this code as input. So it will take those numbers as input. Okay, it will take those numbers as input. and then we'll check if the score is greater than equal to 90, then you need to return A. Okay, if score greater than, sorry, it's not minus, it's equal to, greater than equal to 80, then you return B. Okay, then again another if score greater than equal to 70, then return C. Okay, if score greater than equal to 60, then return D, and else return F. That means fail. Okay, this is my function. Inside process grades, I have another function called get letter. It will take the scores, that means the numbers, then will simply do this grading, I mean letter grading. Okay, so now how I do, since I know that my grades will be a list and it will be a list of numbers, I can run a loop on top of it. So I'm running a loop for number in grades. I'm running a loop on top of it, and then what I'm doing is simply saying print score score, again 5 indentation, score, correct. Okay, score, then simply print, I call get letter. This is what I defined here, get letter. I just call the get letter, and what I will pass the number. It should not be so, it should be number, sorry. I am saying number, so this will be a list of grades, so it will be a number, so I will be running a loop on top of it. Then it will pick each and every number one at a time, and then what I am doing is simply printing number and the get letter number. So now get letter will get each and every number as an input, then it will do this all the checkups. Okay, and my function is done. So now what I do, simply call this function here. Again, input may I need to pass the list of numbers 10, 56, 90, 99, 76, 98, 45, and let's see. So now what I did is simply took each and every number. 10 given f. Why? Because when this function got 10 is even none of the conditions are getting satisfied. So it came to the else and it has printed f. When I got 56, in 56 also lesser than 60, so I got f here. Then 90 is greater than equal to 90, this is true, I got a, so I got a here. So like that this entire flow is mentioned. I hope you have understood this example. Okay, some more example. Okay, so now I'll just show you another example 2, the non-local keyword. Okay, the non-local keyword, I'll discuss about that. What is the non-local keyword? So just for your information, non-local means enclosing. I'll just explain what does that mean here. Okay, let me write one function, define make counter. So this is one of my function, make counter. Okay, in this function I'm defining one variable called count equal to 0. Okay, normal count equal to 0, and while explaining this concept you need to recall the eligible rule that I discussed. Okay, so what I do, first what I do is I will simply define another variable, another function inside my make counter function. So define increment. When increment is something I'm giving. Yeah. Then I'm sorry, my bad. Yeah. Then I'm saying non-local, and you can see non-local became blue color data, right? That means it is nothing but Python built-in thing. Okay, non-local count. What am I saying here? I'll explain. And then I'm simply doing count plus equal to 1, then simply returning count. Okay, and at the end I'm returning the increment. Okay, so first let us understand this function, what is happening here. I am having one function called make counter, in this function I have another nested function called increment. Okay, and there what I am doing, I am saying non-local count plus equal to 1, return count. That's it. Then I am returning increment. Correct. Now what is happening here if I explain? So define increment, non-local count, and all is good. So first of all, this make counter function is returning increment, and increment is nothing but this is that increment that I am talking about. That means the nested function. So this make counter function is returning increment, which is a nested function. Again, this make counter function is not calling increment function. It is just returning me the function. So it is just returning me the function. Later on, if I want, I can call it. But this is just returning me the function. Okay. Now let us see what is happening inside the increment function. So I defined count equal to 0. Right. Now, if you can recall the eligible rule that I discussed few minutes ago, increment, right? Increment. So for increment, for this function, I am saying count equal to, count plus equal to 1. That means this line means count equal to count plus 1. That's what it is, right? Count equal to count plus 1. That's what it is. Now let us say what I want. I am saying that I am saying count equal to count plus 1. But count does not exist in my local space. Count does not exist in my local space. So if I just comment out this line and if I execute the code, I need to call this function below. I'll just call it below to see what is happening. Okay. If I execute the function, say I am getting define increment. Why? I am getting define increment because this function is returning this increment function, right? But now what I do, I just simply store this output in a variable called counter. So I am storing the function output. And what is the function output? The function output is a increment function, which is a nested function inside the make counter, right? So then I am saying counter equal to make counter. Great. So now I am calling it now this increment function stored inside counter. Now how to call it? Like the way we call it counter like this. I am getting an error. Why I am calling like this? Because counter is containing the increment function, right? Because this make counter returned the increment function only. Now you know how to call a function. Now this is how we call any function. Name of the function, then parenthesis. That is how this counter is containing that increment function. And I am simply calling counter then parenthesis. This is calling the function. This is calling the increment function. When this is calling the increment function, I got an error. Unbound local error. Cannot access local variable count where it is not associated with a value. Why? Because when it tried to update count equal to count plus 1, it could not find anything inside the local space, right? Now that's where this non-local thing purpose comes up. So when I'm saying non-local count, I am trying to tell you need to look for count in enclosing space. In enclosing space. What is the enclosing space? This is my make counter function. Inside my function I have the increment function. So this space where this count equal to 2 is defined, that means under make counter, this make counter function is its enclosing space. Like same example I have defined on eligible rule, right? Same thing is happening here. And because of that, I am saying non-local count. I am saying you need to look for count in enclosing space. So I am telling it explicitly. You need to look for count in enclosing space. Okay. And if you see, this increment function is returning only one thing, count. So count is starting from 0, and I am just updating the count with plus 1, and I am just returning that updated count value. Right. So now if I execute the code, see, I got 1. Why I got 1? Because count was 0 at the first point. And this is what I have called this increment function first time. So this count become updated and it got 1. Now if I call again the count, see, it will be 2 now. Why it will be 2? Because count was already updated to 1. So I am calling this counter function again second time. That is why count was already 1 by default. Now it became count equal to count plus 1, that means 1 plus 1, 2. Now if I execute again, see, it will be 3. If I execute again, it will be 4. If I execute again, it will be 5. Because this count values keeps on getting updated whenever I am calling the count function, right? When I'm calling this increment function, this count values keep on getting updated, and because I am saying you need to look for enclosed space, it is updating the count value in this enclosing space, and because of that we are getting the answer like this. I hope I was able to explain the non-local keyword to you. Okay, great. Now what I do, I'll just discuss about few more things, that is lambda function. We discuss about lambda function. Okay, what is lambda function? So it is a small and anonymous, ANONYMOUS single expression function. Okay, so lambda function are nothing but small anonymous single expression function. So what I do, I'll just show you first writing a function in normal way using def. Then I'll show you how we can write the same function using lambda. Okay, so I'm writing one function called, let's say, to the power. Function name is to the power. It takes one parameter, let's say number, and then what it returns? It returns number to the power 2. That's it. That's what it does. And you know how to call this function. I just simply copy it, paste it, pass 2, I will get 4. So I got my output, right? Now let us say I am trying to write the same function using lambda. Now how I will do that? I will type lambda, then lambda is a Python keyword, that's why it is coming as this kind of color. Okay, lambda, then what is the parameter I am passing as an input? Num. Then what I want to do? I want to do num to the power 2. Num to the power 2. Function is ready. So lambda num input parameter, then num to the power 2. See, this function does not have any name. It is anonymous function. It does not have any name. Okay, it's a single expression function and it is a small. So you had to write 2-3 lines for this, right? Now for this you have to write in a one line. It's very easy, right? So now what I do, I simply, now how to call this function? Now to call this function, you need to store this function in a variable. Then only you can call this function. So I'm storing this function in a variable called a square. Okay. Then what I'm doing, simply I'm calling square. Then I pass 3. I'm getting answer as 9. Okay. Great. Now same example, if I show same example, let's say I want to do add using lambda. So I want to add 2 numbers, right? So I'm saying lambda 2 numbers, right? So that means I need 2 inputs, 2 parameters, a comma b, let's say. Then what I want to do, I want to do the addition a plus b. That's it, we are done. Then what is the, simply print add, then 1 comma 2. So 1 became a and 2 became b. 1 plus 2 became 3. It should be the answer. I got the answer as 3. That's it. Okay. And yeah, so I guess I'm good with the lambda so far. Okay, so I'll show you some. It was example 1. Okay, so I just simply comment it, right? Example 1, and what I do, simply I simply do example 2. Okay, example 2. Okay, lambda with sorting. So I'll explain to you how you can do sorting using lambda. Okay, so let us say I have a list of dictionaries. Like I have name, Tanmay. Okay, grade, let's say 85, then comma, another dictionary, name, let us say Mohsina. Okay, and let's say grade 92. Okay, then again name, let's say Ramesh. Okay, and grade, let's say 78, and the last one, let's say name Akshata. Okay, and let's say grade 95. Okay, I got this. So this is my a list of dictionaries that I have. And if I now give you a task that can you sort this list? Can you sort this list? How you try? Let's try this using sorted. You know now, sorted. Then students. What am I getting error? This not supported between instances of dictionary and dictionary. It does not support. How to do it? First of all, your question should be, you want me to sort this list of dictionaries, it's okay. But based on which key you want me to sort? I am saying based on the grade key I want you to sort. I am saying based on the grade key I want you to sort. So if I want you to sort based on the grade key, then that's why lambda comes into the picture. When you call sorted, you can see when you call sorted, if you hover over it, you get someone parameter called key, key key. So that is where this thing comes from. I am saying key equal to, I am using lambda, then x. You can give anything, a, b, c, any name, anything. I am giving x. Then I am saying based on which key you want me to sort. I want you to sort based on a grade key. Now execute the code. Now see. Now things are sorted in ascending order based on the grade. You can see 78 is the lowest one and 95 is the highest one. So Ramesh got the lowest one, Akshata got the highest one. Okay. If I want to sort based on name, I can do based on name too. If I execute the code, see, because Akshata's name starts with A, then M, then R, then T. That's why it is coming up like this. If you want to sort it in a descending order, you can simply say reverse. Again, it has another parameter, reverse equal to true. If you say this, now see, it became in descending order. Okay. So that is how, if you want, you can sort a list of dictionaries using lambda functions. Okay, great. So we'll discuss another example, example 3. Okay. Lambda with conditional expression. Okay, we'll discuss about that too. So I'm writing on function classify. Again, you know, right, whenever you write lambda function, I need to store that in a variable so that I can call it. That's what I'm doing here. Classify. So in the classifier I am saying lambda x. Again, same thing. Now I'm checking if x is divisible by 2. If x is divisible by 2, then you print even. Just follow the way I am writing, guys. First I have written if x is divided by 2, then even. Okay. Else print odd. So if x divided by 2 equal to 0, even, else odd. Okay. This is my function. Done. Now I am calling classify and I am passing 10. So it will return me even. I am calling again classify. I am passing, let's say, 3. Okay. And you can see it is returning me odd. Why it is returning me odd? Because that is the thought process that it follows. Right. So I hope that part is also clear to you guys. Okay. Yeah. So this is how you can write your if else condition if you want to inside the lambda function. Okay. So now we talk about few more interesting topics, that is higher order functions. Higher order function. We discuss about higher order functions. So functions that take, just bold it, take other functions as arguments. Okay. Or return functions. Okay. So higher order functions are nothing but functions that take other functions as argument or return functions. Okay. So there are actually big 3 functions are there. Big 3 functions are there. I just simply beautify them properly. Big 3 functions are there. The first one of them is map, and then is filter, and then is your reduce. Okay. These are the three functions that we discuss: map, filter, and reduce. Okay, we discuss about this these functions. Okay, all right, great. So map, apply a function to every element. Apply a function to every element. That is the map function that we are talking about. So what is the purpose of map function? So again, map is the part of the higher order functions, and I'll explain what is the purpose of the higher order functions. You can see the definition is already mentioned: functions that take other functions as argument or return functions. So that means this map function will take some more function as argument, right? Let's say I have one list of numbers, 1 2 3 4 5. Okay, now what I want to do a square of each of them, and I want to store them in a new list. So I want to return a new list where I store the square of every element inside the numbers list. How you do that? You just tell, let's do one thing: create a new list. Get a new list like this. Then run a loop for I in numbers. Then simply do new list dot append I to the power 2. That's what you do, and at the end you will print the new list. And that should be a step to do that, right? But what if right now we have 5 elements? What if we have billions of elements in a list? Then this loop concept will help you out. It will take a lot of time to get completed, right? You may have a memory issue also. So how do you handle that? Now to handle that, that's why map comes into the picture. So first of all, as we know, map helps us to apply a function to every element. That means we write one function that we apply on every element inside the numbers list. That means on 1 2 3 4 5. So on each and every element I will apply some function, and that using map. Okay, so now what is the function? So what is my goal here? I want to square each and every number, right? So I'm writing a function, define square. It takes one number as input, and it will simply return number to the power 2. That's it. Now I'm calling map. If you see, map takes 2 arguments. It has 2 parameters, func and iterable. What is func? Func is nothing but the function. The function that I want to apply. So I want to apply the square function. Great. Now on which you want to apply? On iterable. What are iterables? Iterables are nothing but these are some concepts that we apply on something on which you can run a loop. Okay, so numbers is nothing but what? Numbers is nothing but it is a list. You can run a loop on top of it, right? So that's what I'm doing here. Now execute the code. So I got one thing called map at this. So this is the memory location of map. This is the memory location of the map. Okay, so map square numbers that I got it here. Map square numbers that I got it here. So since why it is showing it like this, because it tries to store memory, I mean save memory, that is why. Okay, so what I'm doing, I'm saying convert this into a list. I want to see the list, right? So I just want to see 1 4 9 16 25. It has converted everything into a list with a square function applied. Now see, you can write map like this, no problem. Okay, to be honest, but instead of writing like this, you can write a lambda function, because lambda function is also another function only. So instead of writing this much, you can write the same function using lambda. So instead of square function, you can write a lambda function, lambda x to the power 2. That's it, done. Same output you will get. Okay, you get the same output. Okay, so I'll just show you another example. Maybe convert temperatures Celsius, yeah, Celsius, yeah, Celsius to Fahrenheit. He8. Okay, so let's say I have Celsius mentioned here. Let's say 0, 20, 3700. So I have list of temperatures here, right? So what I can do, I know the function, I know the formula to convert Celsius to Fahrenheit. So I'll add a lambda function, lambda C. C means nothing but the Celsius, then round. I'm rounding off the answer, okay? I mean, let's not write round for now. I'll just type round later on. I'm doing C multiplied by 9 divided by 5. Yeah, plus 32. So this is the formula using which you can convert your Celsius to Fahrenheit, okay? C multiplied by 9 by 5 plus 32, okay? And what I do, I'll simply round it off. Comma 1. I'm just rounding off into one decimal place because this function will return me answer in a decimal place. So I'm trying to convert that into single decimal place, okay? So lambda C round, this is the formula that I have applied, and I'll get the answer. So now what I just simply store, I will not store it, I just simply call map now. Now map, I have provided the function, and now I provided the list, that is the iterable that I want to pass, and execute the code. So I'm getting the output and just convert that into a list like this. That's what I'm doing here. And see, I got my my Celsius converted into Fahrenheit using higher order functions. Okay. Now we'll discuss about another higher order function, filter. So this filter is another higher order function. It keep elements that pass a test. It keep elements that pass a test. So I have one numbers here. Numbers equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And 10, correct? I am having numbers here like that. So what I am doing? So I want to use filter function. It keeps element that pass a test. So again, if you call filter, now you use the same thing. When you call filter, it takes two arguments. One, the function, and the one is iterable. But what is the use of filter? Use of filter to filter your data. That's it. So you need to write one function which you pass into the filter, which will return true or false. Why true or false? Because if your function is not returning true or false, how come this filter higher order function will filter something? So let us say I want to write my lambda function. I wanted lambda function, simple lambda function, lambda x or s. I am checking if s is divided by 2. That's what I'm checking. So this function, what it will check? It will check the numbers is divisible by 2 or not. If it is divisible by 2, it will return true. If it is not divisible by 2, it will return false, right? So what I do is simply store in a variable like let's say check, and if I pass check, right? If I call check like this, if I pass 2 here, so it is returning true. Why? Because 2 is divisible by 2. That is why it is returning 2 here. If I pass 3 here, you will see it is returning false. Why it is returning false? Because 3 is not divisible by 2, right? So now based on this true and false, it will filter the data. Now let me just use it. I'm calling filter. I am passing the check as a function. Then I am passing the numbers here. Okay. And just converting that to a list. 2, 4, 6, 8, 10. I got 2, 4, 6, 8, 10. Why? Because 2, 4, 6, 8 and 10 are the numbers who can be divisible by 2, and that's what it has filtered. That's it. We are done with our steps so far. Okay. So I'll show you a few more example of filtering. Same using the same data. So instead of divisible by 2, I'll apply some conditional operation. Let's say not equal to 2. Now this will show only the odd numbers, because if something is not divisible by 2, return those only. Okay. If you want, you can show like this also. If any number is greater than 5, show them only. See, it's showing all the numbers greater than 5. Same, because this is also something returning true or false, right? Okay, great. So I'll show you a few more examples. Let's say I just use the same example. Okay, I'll just use the same example. I just use the student data only. Okay, I'll just use the student data only to explain that to you. Let's say I want to extract those. I want to apply filter on this list of dictionary also. And how I want to apply? I want to fetch those students whose marks are lesser than 90. Whose marks are lesser than 90. So how I will do? I will use filter here first of all. Filter. And then what function? So the function I'm typing lambda. Again, I'm writing lambda function. If you want, you can write your own normal def based function too, but I mostly suggest use lambda. It's easier to write, right? So lambda p. Again, anything you want to give, you can give p. Then p grade less than 90. So this function will return true or false. So wherever it finds grade lesser than 90, it returns that as true. If something is greater than 90, it will return that as false. Now on which iterable, so on which iterable I want to apply that? I want to apply that on students iterable. So that's what I'm saying here. That's what I'm doing here. See, now if I just convert that to a list, you will get the answer. See, I got my name and Ramesh name because we both got numbers lesser than 90. Okay. I hope I was able to explain this to you. Great. Now what I do now, I will show you the last one in higher order function, that is reduce. Reduce, what it does, it combine all elements into a single value. Okay, it is all elements in a single value. So that's what reduce does. It combines all elements into a single value. So let me first import it from func tools. Import reduce. From func tool import reduce. So this is how you need to import something from func tools import reduce. If I execute the code, you will see it. See. So you cannot get reduce directly. You need to import it like this. Okay. Great. So I have imported it from func tools import reduce. So now what I need to do, I am just creating one list of numbers again. Numbers equals to 1 2 3 4 5. Okay. Now I am calling reduce here. Now what I want to do here, I want to add all this number. And that I do using reduce. So reduce function also takes the same thing. If you see, a reduce also takes the same thing. It takes the function and the iterable. So I am writing one function lambda. Since I want to do the addition, right? So I am creating two variables, a comma b, then a plus b, then comma numbers. Okay. If I execute the code, say I got 15. How come I got 15? Let me explain. When I am saying lambda a comma b, then a plus b, then what it is doing? First, it is picking these two values. A is becoming a and b is becoming 2. Okay. Then a plus b, that means 1 plus 2 equal to 3. Done. Great. 3, right? Then now 3 is your a and this 3 is your b. So 3 plus 3 6. Now 6 is your a and this 4 is your b. 6 plus 4 10. Now this 10 is your a and this 5 is your b. So 10 plus 5 15. That's what I am getting as a final answer. So likewise, if you want, you can multiply them through. A multiplied by b. Same R per 120 you will get. Okay. And the last thing, lambda a comma b. So what I am doing here, simply I am checking this. If a is greater than b, so if a is greater than b, so here I am running through one condition. So if a is greater than b, then return a, or if a is greater than b, then return a, else return b. And I got the answer as 5y. Let me explain that also. So I have my numbers here. So my a, like in the first occurrence, my a became 1 and 2 became b. So 1 is greater than 2, false. That means else will be printed b. So in this case 2 was B, so I got output as 2. Then again 2 became A, 3 became B. 2 greater than 3, false, so I got B, that means I got 3. So in the next case 3 became A and 4 became B. So 3 greater than 4, false, so I got 4 because B is 4. Now 4 and 5 same logic, I got 5. So that is why I got final answer as 5. Okay, great. Now the last thing that we have here, that is passing functions as arguments. Let us say I want to pass my function as argument. How do I do that? So that means I'll pass one function as argument. So I'm writing one function def apply operation. Okay, this apply operation take two inputs. One is func, that means one is function, and the one is data. I'm taking one function and other I'm taking the data. So this function will be something will be passed as an argument and data is the data. So what I want, I am considering that this data is nothing but it will be a list of numbers. I'm assuming that when I will call this function, this data will nothing be, it will be a list of numbers. And what I want to apply simple list comprehension for number in data. I'll be simply applying func num. So what is the function that I will define next, but this is the list comprehension that I am returning here. I am calling the apply function. Here I am writing the lambda function. Okay, if you want you can write your own def function too, but I am writing a lambda function. I am simply doing x to the power 3, x cube I am doing here. Then comma data. What is the data? Data is, let's say 1 2 3 4 5. So this is the function that is going here. This is the function going as a function, and as a data it is going a list of numbers. And if I execute the code, I got 1 8 27 64 125. So it has run a loop, and then simply it has returned a nested not a nested, it has returned a list comprehension where it ran a loop. So it picked each and every number one at a time, first 1, then 2, then 3, then 4, then 5. Then it simply did a cube of it. 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125. Okay, so yeah, so that's all I had for today, guys. I hope you have understood the functions, how to work on it. So we have completed the beginner and the intermediate function part. So this is our part 2 that I have covered so far. What will happen next? So next, I think tomorrow only you will get a video on advanced Python functions. So we will cover the advanced Python function, which will be the part 3 that we will be providing it to you, so that we will be done with the entire function era. Okay, why am I uploading everything part by part? Because it's simply because, you know, if I give everything in one video, right, first of all you guys will be confused for sure. Okay, because there's a lot to study, lot to know. Okay, and if I give a part by part, you can complete all the videos in one shot. That is why I am providing in this way. Okay, and once these functions will be done, then we will start with the string methods. So part 3 will come by tomorrow, and I hope you guys will be able to complete this entire section. And if you are new to this video, I will definitely tell you that go to the AI course playlist and start from the day 1, because this will be our day 11, and I want you to start from day 1, because from the day 1 only I discussed about everything. Okay, so if you are new to this playlist, so I hope you guys have enjoyed this video. We'll catch up tomorrow again on the same time. Have a great day, guys. Bye bye.